Yeah, so my name is Dawid Perdek. As Thomas said, I work at Synergy Codes. I'm doing mostly front-end. I'm also a part of BFC. That's because of this Web3 enthusiasm thing. And today there will be no live coding. At first I was like, yeah, sure, let's do it. But then I decided that it might not be the best idea for the first conference speech, so maybe next time. And I'm planning to talk for about 40 minutes. But I'm a little bit stressed, so that may become a little less. Yeah. And there will be a space for question at the end. I'm also planning to give away this small gift pack from Synergy Codes to the person who will answer the question. I will ask in the middle, let's say, of the presentation. Or to someone that will ask the best question at the end, in case no one answers the one that I mentioned. Okay, so one important thing, important note about me, I'm a Web3 enthusiast, but not an expert. So the approach presented today might not be perfect. However, it will be the path that I went through and, well, that worked for me. And actually some details might differ after the demerge event on the Ethereum network, but the general idea of creating, deploying and testing smart contract will stay the same. Yeah, so the goal of this presentation is to show people who want to try creating a smart contract, how to create the first one, deploy it, and test it with a local app on your local machine. So if you feel that you are a Web3 expert, I think I need to warn you that you might be a little bored here. Anyway. Let's start with brief history of web. So who knows what is Web3? Please raise your hand. Maybe I will see that. Pass the light. Yeah, okay, so that's not a lot of hands, I think. Okay, so let's go through that. Web 1 was decentralized, and everyone was hosting their own websites. They were actually owning the website. Or some blog or whatever, but there was no way to interact with that. This internet was basically read-only. Web 2 was all about these interactions. So it was getting more and more centralized over time because of the network effect. Let's take an example of social media platforms. Everyone wants to be on the platform that all of their friends are. So that was giving most amount of traffic and of interactions to small amounts of applications. And these apps were growing very rapidly. Similar pattern was applied actually to the infrastructure solutions. So whoever got the most computing power, most storage space for the cheapest price was chosen as a hosting platform for all of these applications. And that way, we currently have this small amount of applications that receive a huge part of traffic and that are hosted on basically one of three major companies in that infrastructure field. So everyone can create content, post comments, like, dislikes, etc. But you never own your likes, comments, and photos. All the data lies on the side of these platforms, and they can use it for creating profiles and selling, for example, advertising space and stuff like that. So I'm not saying the whole thing is bad. I think actually it's kind of great. But I'm just saying this, more or less, this is how it works. And Web3 is all about ownership. It comes back to the decentralization, helps with managing access to your content, help you make profit from your content. So it is making you not only the contributor, but also like co-owner or ambassador of some product. And Web3 economies are often aimed at win-win situations. So, for example, everybody involved should get some profit. For example, some of you need some service. I can provide it. So you get a service, I get some reward in form of tokens, and for example, someone who brought you to me also gets some tokens. Everybody wins. Yeah, and here this little picture, I think, explains it pretty well. Yeah, so Web 1 was about read, Web 2 added writing to that, and Web 3 adds ownership. And what are the pillars of Web3. I think decentralization is pretty obvious, so let's skip that. And persistence. This is all about keeping immutable history of all the transactions, all the actions, and making it really, really hard for the evil actor to alter that history. Transparency, that should also be clear. But in general, on the blockchain, everything is public. Also the code, anyone can see it, like all the transactions. And important thing for the Web3, sorry, there is no one who you need to ask to join the network, and no one that you need to speak to in order to leave it. You can just start your node or shut it down, and that's just fine. When you're leaving, you can take everything you own, but you won't be able to, because of the previous pillars, you won't be able to remove the trace of your actions that you took while you were on the network. That will lie on the blockchain like forever. And what about smart contracts? This is our main topic for today. So what are they? They are basically just a piece of software, almost like regular web app that some of you are probably working on a daily basis. Something like scripts, like just a piece of software. It can do some math, store some data, emit events, or call other contracts, other pieces of software. Whole code lies on the blockchain. Because of this transparency thing, it is fully visible, and one can audit it. And one can look for bugs, for example. And all the data needs to be present on the blockchain. There is nothing like sending requests to external API for example, for weather data. Everything needs to be on the blockchain because state of the blockchain must be consistent, and each of the nodes must be able to evaluate the method call that you just want to do. And smart contracts gives us possibility to automate a lot of things. They can block funds, automatically block transfers until multiple people sign the transaction, and many, many things more. And the point is, all these behaviors can be automated in a trusted way. And that is something that Web3 gives us. Thanks to these pillars and to the smart contracts, we get trust in the network. And what I mean by that is that we don't need to trust any particular third party, which might have some other interest that ours, maybe even be in conflict with us. And because of incentive systems around blockchain are built for rewarding the maintenance of the network in form of performing calculations, validating results, and stuff like that, we can say that our trusted third party has a form of whole network consisting of huge number of nodes. And all the nodes are performing calculations and validating results with the goal of providing the correct answer. And not the one that they like the most, but the correct one, because this is the only way they can get their reward for the work they do. And correctness of the answer is decided democratically. So, of course, 51% attack is technically possible, but because of the scale of the network, it's really, really difficult. So basically, that means that we can trust the network. And actually, more elaborate example explaining this mechanism can be found in the presentation of one of my colleagues from BFC. I will link that on the last slide. Okay, so at some point, I decided that I want to learn this thing and write my first contract. I found some tutorials, started writing code, and after some time, I was like, well, okay, I have some code. How do I test if that works? I had no idea. And simple answer was just to deploy it and try. But quick question here, who wouldn't like to pay for each call while testing their network? No hands up, so, there are some hands. So, but I see a lot of you are okay with paying for each call. Anyway, that's, I had no idea how to deploy a contract, but what I was sure about is that I don't want to pay for each call while I'm testing my contract. So deploying this on the mainnet was not a good idea for me. And I wanted to test this locally. I wanted to test this locally, but it turned out it's not that simple, just like npm start and everything works. So I decided to look for some other solution. And at that point, I also realized that actually this execution cost is a quality factor for the code that I just wrote. Because, for example, if I prepare a contract that does its job, but each call costs like $1,000, I wouldn't say that that's the job well done. So that's why I thought that that's when I found out about the testnet. And I think it's also not the perfect solution, because in the end they are just mimicking the mainnet, but they are not the perfect mirror. But anyway, using them, you do not have to pay real money for each interaction, but you do pay in fake money. And you do not have to set up a local environment and to actually get some information about the cost. It may not be really reliable, but it's relative information about the cost of deployment or execution of some methods. So we have these testnets, and what other tools do we need? Or whatever happens on the testnet can also be seen in the Etherscan. Although I read recently that after the merge, they started marking these testnets, Ropsten and Rinkaby, as deprecated, but it is still there, still visible. You can still use it. Remix is an online IDE that can be used for coding, running unit tests, compiling, deploying, and probably more things related to smart contracts. Infura is a thing that can be called blockchain proxy. At least I think Shimon Paluch called that in some course, and that makes sense to me, because this is the thing that just hides the communication with the blockchain under the hood and exposes you some endpoint that you just use HTTPS to communicate with. And when you get an endpoint, you need library like Web3.js to communicate with the contract. Other approach, you can use a library like Ethers, which, as I remember, is using Infura under the hood. And having this set of tools, should give you the ability to create the contract, deploy it, create local app, connect all of these things together, and like press a button on your local app and see some changes in the blockchain. So something like manual end-to-end tests, I'd say. Yeah, so now let's jump to our today's example, the one that I created for myself while I was learning and discovering all of these things. So lunch voting token. One of the most important problems in office space, where do you go for lunch or where do you order from? And our token will provide a simple economy that rewards voting for some food and punishes passiveness in the whole voting. Every participant can add some options, but only admin can start the vote. And whenever the vote is starting, some amount of tokens is assigned to each registered participant. They can later spend these tokens on voting. So, for example, you get 1,000 tokens whenever the vote starts, and you can put 500 on pizza, 200 on burger, and 200 on salad, and leave 100 for tomorrow's vote. That's perfectly fine. And option with most votes wins. Whole amount of tokens that took part in the voting are divided between the people that voted on the food that won. And people who did not vote at all are losing all of their tokens. Yeah, so I think that's it regarding this example. And by the way, here you can see Open Zeppelin repository with a lot of examples. So if you want to try writing your own smart contract, start there. You can take this as a base and basically start adding your functionalities right away. Okay, so now let's see. Is it visible? I think it should be good. Let's see some code. So in the top, or maybe that works. Oh, that works. Yeah. So in the top, you can see the method for starting the vote. And as you can see, there is some allocation. This is the amount of tokens I just was talking about. And each of the registered participants are getting this amount of token. This amount of tokens that are minted. So we are increasing the total supply. And here in the bottom, we can see the voting method. So there is a position that we vote on and amount of votes. And this is basically assigned to this position. And we push the address of the voter to this array. What you can see here is a modifier. Here you see the usage, only participant, and that means that these 2 lines of code will be executed before all of this. This underscore tells Solidity where to put the actual body of the method. So yeah, this is a quick example of code. We have one more method that distributes all of the rewards to all of the winning voters, let's call it. Yes, we're basically getting the amount of tokens that should be distributed, and we just transfer them to the winning voters. And here, what is important, you can see the internal. That means that only the contract itself can call it from the inside. It's like a private method. It cannot be called from the outside. If you're not familiar with all of these concepts like internal modifiers, and this code looks weird to you, I'd suggest going to a Crypto Zombies course. It's a really nice place to start your journey with Solidity. This will also be linked on the last slide. Yeah, so we got some code that might work. Let's jump to unit tests. This is a screen from Remix IDE. This slide that is visible on the left. Here you have plugins. You just need to search for unit and activate your unit tests plugin, and then you will get this kind of view. This is where the unit testing plugin lies, and you can generate the like boilerplate tests for each of the contracts you have. You can here choose which contract which test you want to run, and whenever you run it, you will see the output below. And here you can see one fail. That's because one of the methods in boilerplate is designed to just to fail, just to show you how it looks like. And here we have first test. So we are checking if tokens are allocated to the registered participants. We have 2 of them. That's actually my Ethereum addresses. So if you want to send me some Ether, feel free, or your token when you create one. Yeah, we have this arrange section. Then we call start voting with amount of 1,000 tokens, and we check if balance of both accounts. That should be here. The second, the last lines of code. But, never mind. And we are checking if there are in fact 1,000 tokens. Oh, that's great. And here you can see the message that will be shown when test fails. And here. We have additional test checking method is participant. So first of all, we are registering some participant and checking this is a different address, checking if this address is a participant. So it shouldn't be. But as you can see, this test fails. So having in mind previous slide, the question is why did it fail? So I'll give you like, I don't know, 20 seconds. I don't see if anyone raises hand. Gift pack to win. Okay, so if someone raised hand, please make some noise. I don't see it. Yeah? Not exactly. No, the addresses, they are the same. I mean, that's okay, that's not the problem. So the suggestion is to look here. Another ideas? To look here. Here might be the problem.
Maybe the wrong token?
No.
No? Token is okay?
No, it's not the wrong token you said, right? So, not it. Okay, so I will do this. This is the problem. Anyone know? Okay. So Let's go to the next slide, and here is the solution. The problem was here we have before all. So before all of the tests, we are instantiating our contract, and we are registering the participants in the first of the tests, and this will stay there. So we have this address and this address, and the second of the addresses is used also here. So when looking on this particular test, we see that we add one address. We register one address and we check for the other, so it should pass. This address should not be a participant. But in fact, it is because it was registered here. So possible solution, clearing this after each test, or of course using before each instead of before all. Yeah. So in general, unit testing looks pretty standard, I'd say. I think that's it, so we can move on. But before we jump to the deployment and manual testing, we need to compile our contract. So here we have this compile tab. We just hit this button. We need to have our contract loaded in the Remix, of course. We just hit compile and we can go to the deployment tab, where we have a drop-down for environment. Right now you can see the injected provider, which means it will use MetaMask and try to deploy the contract on whatever network is currently selected in MetaMask. But you can also select here something like Remix virtual machine, and this will let you test your contract without any nodes at any blockchain, just like in place locally tested. Here you can provide arguments for the constructor and deploy the contract. When you do that, it will look like this. You have one deployed contract. Like here, we didn't have anything. Now we have one deployed contract, and all of the orange buttons are methods that change the state of the contract. So they will also cost some gas fee. And the blue ones, there are a lot more of them below. The blue ones are read-only, these view methods that are only reading data, and they do not cost any gas fee. And on the right side, you can see the console where you will see all of the outputs, failure messages, success messages, and stuff like that. Okay, so when everything looks good, when we click here, we actually can also record the scenarios. So for example, if you have scenario like register multiple voters, then add some options, then vote, and etc., you can use multiple accounts from here. They are prepared here for you, like 10 or 15. And record the scenario, and then use it as a test scenario. You can rerun it later. Okay, so when everything looks good here, we can go to the testnet. And here, this is important now to have MetaMask here. You deploy again, and then you will get this pop-up from MetaMask, which says that we are trying to deploy the contract, that our gas fee would be $90 almost, so that's a lot, and that we are on the mainnet. And that's the most important thing to check here, because you do not want to pay actual $90 for deploying contract just for fun. And here you should have something like Robster, Rinkaby, or whatever other test network. And then you just confirm the transaction, or in that case, reject. And whenever you do that, you will be able to see your contract in the Etherscan. Here you can notice the name of the network. A contract, of course, can also have some balance. You can send Ethers directly to the contract, and some additional data, list of transaction here below. And when you have that deployed contract, you can start developing your local app and try to connect that to the blockchain. So what you will need for that is Infura. For example, Infura, like example of a blockchain proxy. What you need to do here is create your project and create an endpoint. What is important is network. You need to match the network that you deployed your contract on. You need to take API key and API URL and put that in your local app. And apart from that, you also need ABI, which is Application Binary Interface. You can find it in Compilation tab. Right here, just click it. It will copy whole thing to your clipboard. And ABI is holding information about all of the methods and properties that a contract has. and it is needed by any library like Web3.js or Ethers in order to communicate with the contract. Okay, so this is my really pretty app, my local app. You have some buttons, some inputs, absolutely minimal amount of things that is needed for proving that I can interact with the contract. Responses are logged in the console. Yeah, so it's not pretty far from perfect, but it was enough for my proof of concept. And it stayed that way because that's just fine. Okay, sorry. So repository with all of this, with this whole thing, contract, backend, frontend, everything, is open for improvements. It will be linked on the last slide. So if you want to try working on a smart contract, unit tests, or improve this beautiful web app, yeah, feel free to do it. And let's see a few examples from the code responsible for connecting to the contract. At first, I decided to use Web3.js, and that library needs API URL, wallet key also, contract address, and as you can see, gas limit is hard-coded here with the call. So there is no way to use it together with MetaMask. Sorry. And that's why I decided to keep all of this data in the environmental variables and create additional layer on the backend side and just expose some endpoints for my frontend to use. And because I wasn't able to reject or confirm the transaction using MetaMask, that's why I moved to Ethers and handled this on the front-end side. What you can see here is a method that requests all of the accounts from your MetaMask. So it will create this little pop-up that you will see on the next slide. And then you need to allow your local app to use these accounts in MetaMask. And after that is done, you can interact with the contract. You can create an instance and interact just like contract.name of the method, and that works. Yeah, and I left only one endpoint with ABI and address because I already had that on the backend, so that worked. And with this approach, each transaction will raise a pop-up from MetaMask that requires you to confirm or reject the transaction. So it looks like that. After entering the page, you get this pop-up where you need to allow some accounts to work together with the app. As you can see, we are logged now. And when you press start voting, it will show the pop-up again, and you can reject or confirm the transaction here. Yeah, okay, so all the things that you need in order to create your first contract, your, let's say, dev environment, requires testnets and Etherscan, Remix. This is the most part, actually, of this whole flow. Infura and Web3.js. Or library like Ethers. And apart from that, I know there are a lot of things like Traffic and Assures, possibly others, that can simplify this whole process and improve developer experience. But as I said in the beginning, I'm not showing the perfect way. That using one of these would probably be better. But the one that I went through, it worked. So yeah, good enough. So that's it for the technical part, and now a few words about me, Synergy Codes, and BFC. So once again, I'm Dawid. I'm principal dev at Synergy Codes. That means I'm doing front-end and a lot of other stuff, like also being here and some processes, internal stuff like that. I'm also the member of BFC, where we do a lot of Web3 education stuff. And yeah, feel free to contact me wherever on some Discords or Instagram or LinkedIn, wherever. I'll be happy to help if you have some problems with front-end software engineering in general, or you want to learn Web3. About Synergy Codes, as I said, we do mostly front-end, mostly Angular and React. Something in Node and .NET also sometimes happens. And our main tool is Go.js. This is the diagramming library for front-end visualizations. We are making tailor-made solutions for many industries and more general stuff like organization charts and things like that. And also, you can find us on Instagram, Twitter, and on YouTube. Actually, we are spending some time on preparing this external content, like short videos, some articles. So we think that it came out pretty good. So please check this out and let us know what do you think. And if you want to know more, you can find me after the presentation. And on the other hand, in the BFC, we are doing a lot of Web3 stuff. So we are creating the newsletter and the blog. I'm actually reviewing a lot of these materials, and it's So if you want to know more, you can go to Board Founders Club website, or again talk with me after the presentation. All of the links from today's presentation will be here, so that's easy to remember. Later I will also put here the whole slides, and all of the links will be on the last slide. Also, if you're interested in creating your own smart contract, maybe event like hackathon in Berlin, Hackon Chain will interest you. So if you'd like to participate in such an event, the link will also be there. Okay, so that's it. Thank you.
Okay, thank you, Dawid, for very interesting talk about Web3 and smart contracts. I think everyone enjoyed that and learned something from it.
I hope.
Yeah, well, it seems. Let's see, we've got a few questions on the Discord platform already, so
Great.
I think we'll jump straight into them. So first we have from Conrad. It's a two-part question. Let's take it one piece at a time. Did you have a possibility to work with smart contracts on different blockchains than Ethereum?
Not yet. I'm planning to try something on Solana and Algorand, but for now, not yet.
Okay. But in principle, this is possible and something you want to explore?
Yeah, sure, of course.
Okay. And second part of the question is, what will change in the scope of smart contracts after the Ethereum merge?
So from what I know right now, something changed regarding these tools that I have shown today. Things like Etherscan marking the testnets as deprecated. MetaMask have some problems with propagating transactions to one of them. So I'm not sure how will it end. I hope that this is only like a temporary problems, or they will maybe provide some other testnets. But to be honest, I don't know when or what exactly will they do.
Okay, so it'll be interesting to see.
Yeah.
Okay, and we have another question. This is from Katarzyna. Is there a point with making manual tests on smart contracts? And then there's a comment, I did those using testnet of Ethereum once before by using each possible smart contract option, like adding wallets to whitelists and such. Or is it better to use your approach using software?
I think that makes sense to test it also manually, at least at the beginning, because always writing any code, automating anything is also like more expensive time-wise. It's just easier to deploy it on this Remix virtual machine, for example, and just click the buttons and that's it. But whenever you are closer to the final version, let's say, then for sure it's better to automate that and take care of regression that way also. Yeah, and just avoid human mistake in this whole process.
Okay, so kind of a staged approach.
Yeah,
it's not a one-size-fits-all solution, but
it depends.
Both
like always,
implementations are useful,
yeah.
Depending what you're trying to do. Okay, very good. So if no more questions on Discord, let's turn to the audience here in front of us. Does anyone have a question?
We have one on the right.
There's one. Okay.
So I have one more question, or maybe two. What about unit test coverage? Are you looking at it, or rather not? And the second one, the question is about the impact of the JavaScript language on the Solidity. How do you find it? And maybe the third one, about the integration test or other types of tests, for example, if you are using to test, because you showed the unit tests and also the manual test, maybe some integration tests also.
Okay, so maybe let's start from the last one. Unit tests are like obvious that they were there, that's okay. And I'd say that integration or end-to-end testing is when you have this local app I mean, because having the smart contract on the blockchain is nice, but in general, you want people to use it, and they probably won't use some binary strings to interact with the contract. So we need to provide them an interface. So I'd say this preparing, for example, local app, connecting the button with the blockchain is something like integration or end-to-end tests. And yeah, I think that that's it about the third one. So now the second was about JavaScript influence on Solidity. So me as a front-end developer, I had no problems with entering Solidity world, let's say. So I think there is some influence, but I didn't study the history of the language, so I'm not sure how big it was. But for sure, when you know JavaScript or TypeScript, it should be easy for you to jump in the Solidity, because the syntax is pretty similar. Yeah, so I think there is some influence, but I have no idea how big it is. So I hope that answers, and I don't remember the first one.
About the unit test coverage, are you looking at it?
Yeah, okay, so in that thing that I showed today, there was no indication of the coverage. I guess Remix have some plugin for that, or maybe this unit testing plugin can do it. But to be honest, during my proof of concept, I was not really interested in the data about the coverage. But I saw some articles about that, so I won't tell you the name of the library or whatever. But in general, that's possible to get such data.
Okay, thank you, Dawid, for answering. Any other questions in the audience?
In the middle. Oh.
Very good. Thank you.
Hi. I hope you don't mind me asking a newbie question. So this smart contract, you're putting it on a blockchain. How secure is that, considering I would be using company data? Would that data be visible to everybody using that blockchain, or would it be cool?
You mean you put some company sensitive data in the code?
Yes.
Yeah, so this will be visible basically.
So don't do it.
Yeah,
all right.
Don't do it.
Thanks.
Thank you.
Okay, simple question, simple answer. Anyone else?
Okay, so as I remember, no one answered correctly my question in the middle of the presentation. So I'd say we give this gift back to the friend here on the right. So I will come to you shortly.
Absolutely, it's your show. So.
Yeah.
Thank you once again for a wonderful presentation. Let's give Dawid another very warm thank you for his presentation today.
Thank you very much.